Thank you for the introduction and for inviting me here. Hi, everybody. My name is Boris Vavrik, and I would like to demonstrate you how GitHub Copilot can be a great servant but a bad master. As I expect many of you know how GitHub Copilot works. You are coding, it suggests you something, and it speeds up your monkey work or the work that you are not that skilled at. But one thing that you should remember, that GitHub Copilot is not here to replace the thinking. The thinking should be still your job. I will demonstrate it on a case where we have 2D CT slices with lungs. Either they are present or not. And based on the classification of the slices, we should derive the length of the lung from the 3D CT scan. If you take a naive approach and let just GitHub Copilot suggest you something, you will end up with just imports. You have to give a proper prompt for the GitHub Copilot, but if you ask for the full pipeline, you will run it and it will, no surprises, crash on something. If you want to develop something with GitHub Copilot, you need to know what to do. And one first thing that could be done is to observe the data. You will ask for visualizing the data. GitHub Copilot will give you a prompt where we'll visualize PNGs with the lungs or no lungs on the CT layers, so you have an idea what the data is about. Then you have to build a data set. You ask proper steps. You will get suggestions from GitHub Copilot, and luckily all of them are accepted, run. There is no error, so you can proceed further with the training model, or like before that, the architecture of the model. You will ask for the architecture. GitHub Copilot will provide something. It seems reasonable. There are some convolutional layers, fully connected layers. Everything seems OK. So now we can do the training. When you ask GitHub Copilot to give you the training pipeline, it will give you something within the seconds. And this is the monkey work I like about GitHub Copilot, because I don't have to remember all of the steps. And hooray, after a while, the model is training. And just a few epochs later, you have a model. Now we have a model. The accuracy was increasing. Everything looks fine. So we asked for the application for the use case that we had. The assignment was to detect the lung based on the classification of the 2D layers. So we defined that for the GitHub Copilot, and it will give us a result of 13 centimeters. So yes, we did it. We have a solution just in a few minutes. Everything's great. We can safely conclude that we can code any deep learning model with GitHub Copilot. But that is not true. And the biggest problem is that there are so many issues that you are not even aware of. So let's dig through it step by step, starting with the data observation. When we were visualizing the data, we converted the CT scans to PNGs, and we reduced the pixel size from range -1,000 to 1,000 to 0 to 256, which is almost 90% of information loss, just like that in the first step that you have done. Then, in the dataset creation, there was a random split of the samples, so you have patients both in the training and validation set, which is not a good habit at all. And also, there are no augmentation applied, so you will probably overfit the training. The deep learning architecture was not that great at all. There were like just a few layers, no dropouts, batch normalization, and the biggest problem is like there is no even any activation function between the linear fully connected layers. So that's basically doing nothing if you don't have any activation function between them. The training has its own problems as well. You are not using or optimizing the threshold for classification problem, but the biggest issue is that you print just the train accuracy, and you have even no clue that you are overfitting it because you are not printing any performance metrics about the validation set. And for the application, there is no ensemble, no post-processing, and the result is really unreasonably low. 13 centimeters is like maybe a teenager, not even that, because the realistic result of the lung length is 24 centimeters. If you tackle with all of the problems with much more longer time than the 2 minutes to create the whole code, you may eventually to get something, but you have to be quite an expert to fix all of those hidden problems that were there, and you will get a result that is proper. It's 24.2 centimeters. But that's still not it, because there is a hidden problem that the assignment doesn't really make sense. Like, the assignment was to predict the lung length, but it should be predicted from the whole 3D CT. You should know how it will be used later, the patient cohort, and there are lots of hidden information that the assignment is missing. So what I recommend GitHub Copilot to use for is for any non-critical task that you have, and you can easily control the outputs. It's docstrings, typing, unit tests, maybe some small utility functions that you can validate easily. What I do not recommend GitHub Copilot to help you with is anything that is critical. Cybersecurity, complex functions or algorithms, or especially math, physics, as I can say, because I do a lot of physics, or any kind of statistics. My last advice for the GitHub Copilot is that I recommend it for anyone who is very new to a technology and just want to kick this off, or anybody who is already an expert within the technology and can really validate all of the outputs. But anywhere in the middle, please rely on yourself, because that's the only way how to safely develop and become better. Thank you for the presentation.